Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it. Hook, imagine sitting in an exam, you've done the algebra, you write an answer, and the examiner crosses it out because of a tiny sign mistake. It happens more than you'd think. Last year, one completing the square style question lost more marks than any other single part on a higher paper, not because the maths was hard, but because students missed a minus sign or forgot to divide by the leading coefficient.
Sound familiar? I always think I know how to do it, then one little slip ruins it.
Promise, by the end of this episode you'll understand why completing the square works, how it helps with sketching and solving quadratics, and one 10-second check you can do every time to catch almost all sign and balancing mistakes. Let's work through this step by step.
The concept. Start simple. We usually see quadratics written as ax squared plus bx plus c. The goal of completing the square is to rewrite that as a times x minus h squared plus k. Why? Because hk is the vertex of the parabola, the highest or lowest point, and the axis of symmetry is x equals h. That gives you instant information for sketching and for optimization questions.
First step. If a isn't 1, factor it out from the x squared and x terms. For example, take 2x squared minus 8x plus 3. Factor 2 from the first two terms to get 2 brackets x squared minus 4x plus 3. This keeps the expression equivalent. We haven't changed anything, just grouped terms so the x squared has coefficient 1 inside the brackets.
So always factor the leading number out of the first two terms, even if it's negative.
Exactly. If a is negative, factor a negative. Write it cleanly so you don't lose a sign later. Next, inside the bracket we have x squared minus 4x. To complete the square, we take half the coefficient of x. That's half of minus 4, so minus 2. Then square it. Minus 2 squared equals 4. We add and subtract that 4 inside the bracket, which keeps the expression unchanged overall.
So we write 2x squared minus 4x plus 4 minus 4 plus 3. Group the perfect square. 2 multiplied by x minus 2 all squared minus 4 plus 3. Then distribute the 2 back in. 2 multiplied by x minus 2 all squared minus 8 plus 3, giving 2 multiplied by x minus 2 all squared minus 5. That's vertex form. A multiplied by x minus h all squared plus k, with a equals 2, h equals 2, k equals minus 5. The vertex is 2 minus 5.
Oh, I always forgot to multiply the subtracted number by the 2 outside. That makes so much sense now.
This is where many slips happen, forgetting to distribute the leading coefficient or dropping a minus sign when halving the b term. A quick rule. Write the step explicitly. Factor, halve the b, square it, add and subtract inside, group, then multiply the outside factor back through the subtracted term. Write it down. Examiners love clear steps. Now, why does this algebra work? Because x squared plus bx can be seen as x squared plus 2 times b over 2x. Adding b over 2 squared completes the square, because x plus b over 2 squared expands to x squared plus bx plus b over 2 squared. We add and subtract the same number, so we haven't changed the expression. We just reveal the perfect square inside. Let that sink in. We aren't cheating the algebra, we're rearranging it to expose the vertex.
Where this helps in exams, solving equations, sketching graphs, and finding maxima or minima. If you need to find where the graph crosses the x-axis, you can set a into x minus h squared plus k equals 0 and solve. If you're asked for the minimum value, you can read it straight from k when a is positive.
The exam technique. What do examiners want to see? I'll give you a typical 3-mark layout for a solving question that uses completing the square. Mark allocation often runs M1 for a correct rearrangement or division to make the x squared coefficient 1, M1 for the correct completion of the square, showing the plus-minus term and grouping, and A1 for the correct final answer or value. Sometimes there are 2 M marks and 1 A mark. Other times an extra M is given for explicit substitution. The key is visible method.
So if I can't finish the last arithmetic step, I can still get method marks by showing the right setup.
Exactly. Write your setup. For the example 2x squared minus 8x plus 3 equals 0, show 2 in brackets x squared minus 4x plus 3 equals 0. Then 2 in brackets x squared minus 4x plus 4 minus 4 plus 3 equals 0. That line alone earns method credit because it shows the correct approach. Even if you stumble on the final arithmetic, examiners can award M1s for correct method steps. Write it down, don't just think it.
Common marking mistakes to avoid. 1. Not factoring out A when A not equal to 1. 2. Halving B incorrectly. Remember, it's half of the coefficient inside the bracket after factoring. 3. Failing to adjust the constant when you add and subtract the square, especially after distributing A. Also, label your final answer clearly. If the question asks for the vertex, write vertex equals HK, so the marker can award the final accuracy mark.
Quick win. 2 quick checks that take 10 seconds and catch most errors. I call it plug and mirror. Plug, substitute the vertex x equals h back into the original quadratic to check the y value, k. Mirror, check symmetry. The axis x equals h is the average of the roots, so if you have roots r1 and r2, r1 plus r2 divided by 2 should equal h. 2 checks, 10 seconds, massive payoff.
Can we see those checks on the example?
Yes. From earlier, we found the vertex 2 minus 5 for 2x squared minus 8x plus 3. Plug check. Substitute x equals 2 into the original. 2 times 2 squared minus 8 times 2 plus 3 equals 8 minus 16 plus 3 equals minus 5. That matches k. Mirror check. If you solved 2 times x minus 2 squared minus 5 equals 0 for roots, you might get r1 and r2. Their average will be 2, which is h. Instead of finding both roots, use the formula minus b over 2a, which directly gives h. For 2x squared minus 8x plus 3, minus b over 2a equals minus 8 over 4 equals 8 over 4 equals 2. Quick and reliable. Mnemonic. Plug and mirror. Plug the x value to confirm the y. Mirror the roots across the axis. Write those 2 words in the margin when you finish completing the square question as a prompt to check.
Worked example recap. Let's walk through a full GCSE style question out loud and show the exact lines to write. Question. Find the vertex of the curve y equals 2x squared minus 8x plus 3 and hence state the minimum value. Step 1. Write y equals 2x squared minus 8x plus 3. Step 2. Factor. Y equals 2 times x squared minus 4x plus 3. That's M1. Step 3. Complete the square. Y equals 2 times x squared minus 4x plus 4 minus 4 equals 2 times x minus 2 squared minus 4 plus 3. That's M1. Step 4. Simplify. Y equals 2 times x minus 2 squared minus 8 plus 3 equals 2 times x minus 2 squared minus 5. A1 for the vertex, 2 minus 5, and an extra A1 for minimum value minus 5 if asked clearly. Write vertex equals 2 minus 5, minimum value equals minus 5. Read the steps aloud as you write them in an exam.
I like how you labelled M1 and A1. That shows what to aim for.
Exactly. If you ever feel stuck, remember method marks exist to reward your steps. Even partial answers can earn marks if the method is clear. Don't skip the check. Plug the vertex back in and use plug and mirror. That 10-second habit catches missing negatives and misdistributed factors more often than you'd think.
That's your quick win for today. If this helped, share it with a friend who's revising.
You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.